JAX 2015, wir sind immer noch in der Mainzer Rheingoldhalle natürlich. Ich freue mich jetzt, dass Matteo Cantarelli bei mir ist. Er ist Co-Founder des Projektes Open Worm. Ich werde jetzt auf Englisch umstellen und wir werden uns auf Englisch unterhalten. Matteo, nice to have you here. Nice to meet you. Please introduce yourself a little bit for our audience.
So I'm Matteo Cantarelli. I'm one of the co-founders of the Open Worm project. My background is a software engineer. That's what I've done for the past 10 years.
Okay. Open Worm, the project. It's a science project to digitally reconstruct a whole organism.
Correct.
Actually, a worm, of course, as the name is saying. It's also the topic of the keynote you're going to deliver here this evening. Please elaborate on some of the principles of this very interesting project.
Yes, so the idea is to basically build in order to understand. So it is a project that is finalized at an understanding of the worm, and in order to do this we are building a model, which means putting together decades of efforts from science together and basically creating a model that can replicate the different behaviors of the worm.
Okay. You're the co-founder. How did the whole thing originate?
Well, that's a very interesting question because the answer is from a tweet, really. So basically, turned out there were different individuals that were thinking about creating a project like this. So there was at some stage from one of the other co-founders, a friend of mine, that was tweeting, oh, New Year's resolution, you know, simulate the C. elegans. Another guy, the other side of the world, was like, oh, that's interesting. How you plan to do that? We started talking, and we went from a couple of us to more than like 40 collaborators now.
Okay.
So,
and it's multinational, the team?
Yes, the whole team is scattered throughout the world.
So how it's throughout the world, and how do you guys collaborate? What technologies do you use?
Well, internet, basically, things like Google. Well, we started with Skype because it was 2011, Google Hangout wasn't there yet, at least not as we know it. So it started on Skype, it started with emails, and now it's like Google Hangout, bi-weekly meetings, Google Docs, a lot of Google Docs, and obviously a lot of Git and GitHub in order to share the code.
Okay. Can you please describe the progress you've made right now? Again, it's Open Worm, a project of simulating the behavior, let's say, of a worm, a real-life worm. I think it's called C. elegans, this worm.
Yes.
In German, it's ein Fadenwurm, I believe.
I won't try to say that.
Yeah. Please elaborate a little bit on the progress you've made so far as this simulation is concerned.
Okay, so we started from scratch. That is the important thing, as in there was no project, there was nothing. And the first thing, I suppose the first half of the first year went just trying to understand what kind of approach would make sense. So there was a lot of, if you wish, in software engineering terms, requirements gathering for the simulation and also use cases, etc., etc. What we started working with is the locomotion of the worm, which is one of the most primitive and simple behaviors that are there. Because the worm is very interesting because it can do a whole lot of things. It's like it can exhibit social behavior, it can do mating, it can look for food, all very fancy things that requires a lot of different things to model inside the cells.
Okay.
And but we're starting from a model which is about the locomotion, and we are working towards integrating a model of the body of the worm with the muscle cell and a model of the nervous system. Obviously, these things, it's not like you do it once and that's it. It's like by nature it is highly iterative. So you have to constantly go there, change your model and improve it in order to get closer to something that actually makes sense. And we're building a whole pipeline to process videos of the real worm so that we can extract features from the movement of the worms, features that we can also extract from the simulations that we're building, so that then we can compare them and build a sort of like unit testing environment for the model.
Okay.
So this is where we are. All of these things takes
right now. Okay.
A lot of time.
You mentioned muscles, you mentioned the nervous system. Please explain to the German audience what the aspect of locomotion really is in this case.
Well, basically the worm moves, and in order to move, it means that you do have, if you look at the reconstruction of the worm, you do see that there are basically bundles of muscle cells on the side of the worm, and these muscle cells are capable of contracting. Now, depending on how they contract, the worm changes its shape.
Oh, okay.
and because of friction, then it starts moving. But what makes those muscle cells contract or not, and in what sequence to originate one kind of locomotion or another, forward locomotion, backward locomotion, how much the worm bends. These information are passed from the nervous system, and you have to model basically the neurons of the worm and their interactions with the muscle cells, so that some signals, some, you can think of variables that make sense for the nervous system, can then affect and translate into something that makes sense for a model which is about the muscle cells.
Okay. Although one would think a worm is a simple creature, all that you're talking about sounds highly complex. Just tell me, as far as, for example, data is concerned, how much data and how much info, basically data, are you accumulating right now? Can you give us a number, or how much stuff have you accumulated, like in gigabytes or terabytes, or is there anything you can tell us about this?
Definitely we have, like if you think of, I was talking about the pipeline for the validation. So in terms of that, we have, for instance, 5 terabytes of videos that just describe these features of the real worm. And in terms of, basically, in terms of the model themselves of the nervous system, basically the amount of data that you have depends on the level of abstraction that you place yourself. So it's like if you were thinking of something like a holistic model where every cell is modeled to the level of details of molecules and atoms, then you would obviously have a computational explosion in terms of how much data you have. So the main purpose and goal of the project it is basically to understand what is the level of abstraction which is enough in order to explain the behaviors, but not too much. Otherwise, you just don't get there, and you build something that is as complicated as the thing that you're trying to explain, which defeats the purpose of the model.
Okay. Going forward, what are, in your mind, the biggest challenges that you're approaching right now in continuing this project?
Well, there is a lot of data that still needs to be gathered, acquired, and understood by science. So this basically, we talked about the nervous systems and the muscle cells and how these talk to each other, but then if you want to characterize the dynamics of each one of the neurons, then you need to have a model for this neuron. In order to have a model of this neuron, you need to have devised some kind of experiment that allows you to create this model to begin with, to understand what goes on. And the worm is not the simplest organism to do this. It is much easier to do it, for instance, in rats, where you can just stick an electrode in the neuron, and then you can measure things like how the current and the tension changes across the membrane of the neuron, while if you do the same kind of technique with the C. elegans, the worm would just explode because it's pressurized. So there are now advanced imaging techniques that are being used in order to visualize, for instance, things like the concentration of calcium in an in vivo moving living worm. And these things need to be segmented, understood, so that then they can translate into the model. There is a lot of work still to do.
Okay, I see. It sounds very complex. You started the project, or it was funded also by Kickstarter?
Well, after that came after, I suppose, 3 years, we decided basically to try the Kickstarter as a mean to basically fund what is an independent from academia project. We collaborate with many academic institutions, but we are not affiliated with any of them in particular. So in order, all the people that work in OpenWorm do so on a volunteering basis, but as the project kept growing, basically we needed some kind of way of financing basically this growth. And it can be in terms of server time for running the simulation. It can be in terms of like going to conferences, get together, because it's like you do everything in a virtual way, but sometimes you do need, and it is nice to sit across the same table of someone that you have been speaking with for 3 years. So we did a Kickstarter in order to have some little money in order to do these kind of things, and we succeeded, and we raised $120,000.
$120, okay. Well, there are always, you know, like these offers for the first backers or for the backers who put a lot of money into it. I think, as I read, you as a reward, you made available to your backers that they had access or will have access to a partial simulation of the worm in the browser. Is that still on the map, or did you already realize it?
That is still on the map, and that is something we are doing. We're calling it the worm sim. And basically, one of the things that OpenWorm is doing differently than traditional science is not only to do everything open. Basically everything we do, code, etc., is publicly available. But also we want basically to reach out to people that would not otherwise have the means to really deal with something this complex. Therefore, we are building an application that would allow OpenWorm to expose the models that we are building, and it will be something like one of those products that will improve over time. So at the beginning there will be the models that we have now, and we'll be releasing at the end of June, and then over time there will be more and more models, and we'll basically make more progress. But all of these will be in the form of a web application that will be usable and accessible through the web browser.
Very cool. Another very cool thing which I read and saw a little bit of is you made, or the simulation of the worm's brain was used to control a Lego robot.
That was interesting indeed. It was one of the contributors of the OpenWorm that basically took what was the connectome, which basically represents how the different neurons are connected to each other, and basically created a simple program out of this. I wouldn't call it the brain of the worm because there is a lot of complexity that is not captured. It's like a cute experiment, but that was basically plugged into a robot that basically I think it was very interesting for one reason, because it is thought-provoking. It basically, although we're not there yet, it shows that one day we could have things like robots that are basically driven by something which is biologically inspired, and we could have much better and intelligent networks driving this. So it's like we're reverse engineering nature in a way.
How would you explain, or is there, I'm sure there is, a connection of your project to artificial intelligence research projects? How close are you to them? Is it a part, or?
Well, it is a different angle, but like artificial intelligence is something that I was, for instance, very interested in historically. You know, as probably every software engineer, software person, at some stage you're kind of attracted by these things that are more intelligent software. But what we're trying to do is to basically start from the biology and go bottom up. So rather than trying to figure out an algorithm which is intelligent, we're putting together the pieces as biologists put them together and look at what emerges. They will meet at some stage, and we will gain precious insights also for artificial intelligence, but it's just, you know, a slightly different perspective.
Approach. Yeah, okay. You mentioned that the whole project is open source, and people are, and of course we have a lot of developers watching this, people are invited to participate. What forms of participation are you offering? What can people do to help you?
Well, there is, I suppose the audience of this is maybe a lot of Java developers, for instance.
Sure, yes.
So we do have our platform that we're building that is called Gepetto, and the backend is written in pure Java with OSGI and Spring, things like that. It is all public on GitHub. It is MIT licensed. So we have every 2 weeks a meeting that basically everyone is invited to. Always, please join. And we have the whole process in terms of what roadmap we have and what features we intend to build lined up in public. So everyone that basically goes to the website will find a way to access a sort of a Kanban board with all the tasks and all the issues kind of thing, so that they will be able to just write, if they have a GitHub account or an email, whatever, and say, hey, I know a bit of the technology that you're using in this, and we would be interested in contributing. And the community, that's how the community has been growing for the past 4 years.
Matteo, thanks a lot. Very cool project. Thanks for telling us about it, and have fun at the conference, and of course during your keynote. Thank you.
Thank you.